Well, hello again. I'm going to talk to you today about rational expressions, and hopefully the storm that's going on outside my room here is not going to come through on the video, but if you hear a couple of booms, that's just the thunder. Okay, so I'm going to start this video. We're just going to focus on an introduction to rational expressions right now. And so let me just remind you, what is a rational expression? A rational expression is actually an expression that can be written as a fraction where the numerator and the denominator is a polynomial. So for instance, 18x cubed over 3x squared, you have a polynomial in the numerator and a polynomial in the denominator. X plus 1 over x minus 1, you have again you have a polynomial in the numerator and a polynomial in the denominator. And then of course here's one that with a trinomial in the numerator and a trinomial in the denominator. So those are examples of rational expressions. Now, one thing that you have to worry about with rational expressions is since they have a denominator that generally going to involve a variable, you need to determine what values of that variable will make the denominator equal 0, and then you have to exclude those values from the domain. So this is important later when we get into solving equations. You might get an answer that's not in the domain, and of course if you do, you can't use that. So let me give you some examples here. On this one, if I have 18x over x cubed, well, the only way that x cubed would be 0 is if x is 0. Because x is 0, then you'd have 0 cubed, which is 0. So basically what you're doing is you're setting x cubed equal to 0 and solving it, and then you're going to say that the domain cannot include that. So the domain here is x cannot equal 0. Now let me show you another way that the domain might be written, but I'm not going to do this on every one of these. But let me just show you here another way the domain might be written in interval notation. Okay, so if I wanted to write this x can't be 0 in interval notation, what I would do is I would say the domain is everything to the left of 0, which would be negative infinity to 0, plus everything to the right of 0, which would be 0 to infinity. And of course this is the union symbol. Now basically what this does is it just shows you everything on the number line except 0. Since these are parentheses, it implies 0 cannot be included. So I won't do this on the rest of them, but you know, if your instructor wants you to write the domain using interval notation, then you need to be aware of that. Okay, so now on this one, what I need to do is I need to factor the denominator, because when I want to find out what makes a quadratic expression equal 0, one way to figure that out is to factor it, and this factors into a plus 3 times a plus 2. And then what you do is, you know, you remember before we talked about how to solve these equations by factoring. So you set that denominator equal to 0, and so that means a plus 3 can't be 0, and if that's the case, then a can't equal negative 3, because if a was negative 3, then you would be dividing by 0 here, which is not allowed. And the other value that a cannot be is a cannot be negative 2, because if a is negative 2, then you would also be dividing by 0. Okay, so here is the number 3 here. If you notice, you have another quadratic expression in the denominator. And so if we take that and set that denominator portion equal to 0 and solve it, we'll see that y equal 2 or y equal 1 will make the denominator 0, but remember that's what we don't want to happen. So we say the domain is all real numbers except y equal 2 and y equal 1. So those are the numbers that must be excluded there. And then on this last one, the denominator is x squared minus 4. And then so if you factor that, then what will happen is it will factor into x plus 2 and x minus 2. And if you figure out what makes this equal to 0, then you'll see that x would equal negative 2 or positive 2. So that's what we cannot allow that to happen, because if x is negative 2 or positive 2, then this expression would have 0 in the denominator. And of course that's what we're trying to avoid. Now the next thing I want to do is I want to show you how to simplify a rational expression. So here I have 18x over x cubed. So you might be able to do this in your head, but let me show you how I did this. I know the denominator x cubed can be written as x squared times x here, and then that allows me, I can actually cancel x over x, because remember x over x is 1, so then I would just have 18 times 1, which is 18, and in the denominator I would have x squared. So that would just be 18 over x squared. Now if you have a more complicated polynomial in the numerator and denominator, then what you want to do is try to factor. So here I have a squared minus a minus 6, and that will factor, and again you might want to review your factoring techniques, but that will factor into a minus 3 times a plus 2. And then we saw earlier that a squared plus 5a plus 6 factors into a plus 3, a plus 2. And then notice we have a common factor in the numerator and denominator of a plus 2, so a plus 2 over a plus 2 is just 1. So the answer here would just be a minus 3 over a plus 3, which is what I've got written right here. Now on number 3 here, I have 3 minus 2y minus y squared over y squared minus 3y plus 2. I don't like having this trinomial written this way with the minus y squared. So what I'm going to do is, and you can see I'm going to do it down here, I'm going to factor out a negative 1. So I'm really factoring out a negative 1 right there. But you know, you can just pull a negative out. That's the same as factoring out a negative 1. And what that'll do is that'll change the sign of each of these. Like the 3 would now be minus 3, the minus 2y would now be plus 2y, and the minus y squared is plus y squared inside the parentheses. And of course I rearranged the order because I prefer to have this written in descending order. Now I can factor the y squared plus 2y minus 3. That factors into y plus 3 times y minus 1. And I still have the negative 1 factor right here. And then in the denominator, I can factor the y squared minus 3y plus 2 into y minus 2 times y minus 1. And then what I can do is, I know that y minus 1 over y minus 1 is just 1. And so this is just minus the quantity y plus 3 over y minus 2. So I can write it like that. Or I can also write it this way. Let me pause it so I can show you another way you could write that. You could also put the minus in the numerator, but if you do that, you want to make sure you put the numerator in parentheses. I don't really see any reason to distribute the negative through here, but you could do that as well. Okay, now on this one, I have 4 terms in the numerator. And remember, usually when you have 4 terms, the way to factor that is by grouping. So if you group the first 2 terms here, then you'll see you have a common factor here of x cubed that I can factor out. And then that will leave me with x here and plus 2 here. So that gives me x plus 2. And then in the last 2 terms, I can actually factor out a negative 8. And if I factor negative 8 out, that's going to give me x plus 2 as the other factor. Now, the next thing I have to do here is I notice that I have x plus 2 in this factor, and I have x plus 2 in this term. I'm sorry. In each term I have x plus 2, and I can factor the x plus 2 out. And if I factor the x plus 2 out, I'm left with the x cubed minus 8. Now, the denominator is simply difference of squares, so I can factor that as x plus 2, x minus 2, and I just brought it down here in this step. Now, you notice that x plus 2 over x plus 2 is 1, so I can cancel that, and I get x cubed minus 8 over x minus 2. Now, you might incorrectly think you're finished here, but if you'll remember from our factoring techniques, remember that x cubed minus 8 is actually difference of cubes, and so we can factor that using the difference of cubes formula into x minus 2 times x squared plus 2x plus 4, and then that allows me to cancel x minus 2 over x minus 2 since that's a 1, and the final answer is just a trinomial x squared plus 2x plus 4. I want to finish this with just one comment. If you have a rational expression where every factor in the numerator cancels with every factor in the denominator, make sure you realize that that would be 1 and not 0. Some students mistakenly think that's going to equal 0, but it's going to be 1 because x minus 2 over x minus 2 is 1, and x plus 2 over x plus 2 is 1, and of course 1 times 1 is 1. Okay, so that completes the introduction section to rational expressions, and in the next section I'm going to show you how to multiply and divide these rational expressions.